Hi guys, it's me again. So this time I would like for you guys to look at your Stemscopedia and your notes on OneNote. And if you notice up here, part of the assignment is a PBS virtual lab. There is a link right down here. It's a simulation that I want you to go through. And you can use that simulation to help you complete page 6 on your page 6 in your Stemscopedia, where you have to draw the atom and understand the atom. So if you guys will look at your OneNote, and on your OneNote, I have a couple areas that I have highlighted. I'm going to move my picture over here so that you can see this. So in the areas that I have highlighted, here we have our world is full of various substances we call matter. Matter is anything that takes up space, has volume, and has mass. So I also have this highlighted. So remember, when you are highlighting, I would like for you to highlight green if this is something that you know. You can highlight yellow if you need to look back of it, or kind of a rose color if you really need to study it. To highlight, remember, go up here to the draw and click on the highlighter, okay? So if we look right here, that section answers our very first questions. Now, I do not care if you guys print out your notes if you want to. I may start copying them right next to this so that you guys can see it. So our question here is, what is matter? It's anything that takes up space, has volume, and mass. Some examples that it gave you had to do with the car, and it mentioned the metal in a car, the glass in the windows, those are all solids. We have gas and oil, which are liquids, and we have auto exhaust, which is a gas. So here we see that it occurs as elements, compounds, and mixtures. So we have elements like the iron and the carbon, and we know that there are more than 100 elements. We have compounds such as the silicon and oxygen gas, and we have mixtures like the gases that we have in the air. Okay, so if we look over here, it mentions that we have, for example, metal car frames are typically hard steel made from the elements iron and carbon. Use those as your examples. The glass is a compound made of silicon and oxygen. And then the exhaust is a mixture of the gases such as carbon dioxide. We know that there's more than 100 different kinds of elements, and they each have their own type of atom. So these atoms are tiny particles that serve as the building blocks of all matter. And that's kind of another section right here. And it says a bar of the element gold over here contains quadrillions of individual gold atoms. So if I took that bar of gold and I cut it down to the very tiniest piece, I would only be able to get it small enough to see one gold atom. And so every single atom of gold is going to be the same. Every single atom of hydrogen is going to be the same. Every single atom of carbon is going to be the same. So we know an atom is the smallest particle of an element that cannot be broken down without changing those properties of that element. We look over here at our notes. Okay, what is an atom? Atoms are the building blocks of matter. They are the smallest particle of an element. They're very small and too small to be visible. A single atom of an element has the same properties of every other atom of that element. That's why I said like every atom of gold is going to be the same. We look over here, kind of like what are atoms made up of. So what are atoms made up of? All atoms have the same general arrangement of subatomic particles, and that's what we call the pieces that make up the atom. So we know that they're made of positive protons and neutral neutrons, which kind of, if you look at the word, it helps you remember they're neutral. So positive protons have a positive charge, neutral neutrons have no charge, and they are in the center surrounded by a cloud of electrons, and the electrons are negatively charged. So So it says scientists refer to this structure as the electron cloud of the atom. So we have the atom is the smallest particle of an element. It is made of electrons, protons, and neutrons. And if you watched the little video, I think I posted it for you guys, the WKRP video, it's kind of cool because it does show you that the protons and neutrons are inside the nucleus. So here, a single atom of an element has the same properties of every other atom of that element. It is made up of positive protons and neutral neutrons and negative electrons. All of these are known as subatomic particles. All atoms have the same general arrangement with protons and neutrons in the center, which is the nucleus, and it is surrounded by a cloud of electrons called the electron cloud. Okay. Now, if I scroll down here, the electron cloud model, which is over here, of an atom is more accurate in its depiction of the electrons than the older atomic model over here. This is the older atomic model developed by Niels Bohr in 1913. If you think about it, that's pretty amazing that they could come up with a model like this. They didn't even have an electron microscope to be able to look through. And so when we look at things, this kind of reminds me of the solar system, where everything like shows you like the solar system. It looks like it's all flat in a flat plane, and it's not. These electrons are like going all different directions like this around the nucleus. And so in the electron cloud model over here, the nucleus right here is surrounded by negatively charged electron cloud, where the electrons travel in high probability areas called orbitals. So this Bohr model over here is often used to be able to show you the placement of the electrons in the different orbitals. Both models describe a very dense, right here, central nucleus that is composed of positive protons and neutral neutrons. And so here it means it's very dense and it's very compacted. It's heavier, but it is compacted, so it's a lot smaller. Whereas our electrons can be like way out there flying around. I want you to notice here that we have this first orbital. Notice how there are just two. There's 1, 2, and this is a oxygen atom. So that means that this first orbital can only contain 2 atoms. This orbital here can contain only 8. We'll talk a little bit more about that. Okay, so we look over here and we say, what is the electron cloud model? It is more accurate than the older Bohr model, which was developed in 1913. The model where the nucleus surrounded by a cloud of negative electrons that travel in high probability areas is called the orbitals. And then both models have very dense nucleus of positive protons and neutral neutrons. Okay. Move down here to your notes. And feel free to stop these at any time so that you can kind of make sure that you have this stuff labeled. The location and charge of what we call the subatomic particles determines the structure of the atom. So here we have protons, neutrons, and electrons differ from each other in their location in the atom and their electrical charges. So the electrical attractions and repulsions between these charged particles, like the atomic nucleus, which is positive, and the electrons, which is negative, in matter explains the structure. So here we have nitrogen, sulfur, and iron. And nitrogen has 7 protons, which are these red dots. So we have 7 positive protons. Sulfur has an atomic number of 16, so we have 16 positive protons. And iron has an atomic number of 26, so we have 26 positive protons. Okay? Now, the number of protons is also the same as the atomic number, and that determines what element it is. So the whole periodic table is set up by the number of protons that an atom might have. Down below it says Neutrons are shown as yellow spheres. They do not have an electric charge. They are neutral. So we have neutral neutrons, and they are found in the nucleus of this atom. And the protons are important because it determines what element it is. The neutrons are important because they hold that nucleus together. So then we have electrons, these negative electrons, and they travel here in the electron cloud around the nucleus. They are constantly moving at nearly the speed of light. We use these Bohr models, like I said, so we can kind of look at where all of these electrons are placed in which orbitals, and what we talk about are energy levels. Remember I said this first energy level or orbital can only contain two. So we have nitrogen that has two in the first orbital, sulfur, and then iron. To me, I always think of it as like a coffee cup sitting on, or a cup sitting on a saucer, and you fill the coffee cup and it spills over. It can only contain so much and it spills over to the saucer. So on here, we have that where it is going to spill over into this level. The second level can only contain 8 electrons. And so after this first orbital fills with 2, it will go to the next one, which is 8. And then once it fills up with those 8, it goes here. Notice that we have 7 protons and 7 electrons. We have 16 protons and 16 electrons. So we have the same number of protons, positive protons, that we have negative electrons. If all of our protons are positive and the neutrons are neutral, then our nucleus is going to be positively charged. Okay, and if we have the same number of positive as we have negative, that means it's neutral. So we would take like 7 positive minus the 7 negative, and then we would end up with 0. Okay, over here, what is the atomic number? The atomic number is the number of protons in an atom. It identifies the type of atom. Example, we have nitrogen with 7 protons, sulfur has 16, and iron atoms have 26. Okay. The next section on atomic mass and volume, I am going to kind of do another video, so I kind of do them in bits and pieces. You can look back on this as much as you need.